All right, we are going to talk about an iPhone 6 and 6 Plus epidemic. It is the sudden loss of touch function. So this is a defect at the motherboard level. What we've learned just by seeing a ton of these is that there seems to be a defect either in the chips used or in the manufacturing process itself that leads to really, really weak joints under the touch IC chips on the iPhone 6 and 6 Plus. There's two chips. There's the Cumulus chip and there's the Mason chip, and both of these can be affected by even a minor drop or really nothing at all when all of a sudden touch stops working. If you have a phone where you suddenly have no touch, then of course doing a hard reset would be your first option. So top power and home button together for 10 seconds. And if that doesn't solve, you can try to look for software solutions or anything, recent changes you might have done. But more than likely, because this is just such a common issue, you're going to find that you have a hardware defect. So replacing the screen, you get no touch, put on another screen, you still have no touch. When you're troubleshooting with known good parts and you have a problem, then that points to the motherboard. So I've got an example that I want to show you how to fix iPhone 6 and 6 Plus no touch problems. So this one here came to us for repair, and it came to us board only. So I have the board here. I'm going to prompt it to wake up. All right, so here we are, and we should be able to slide to unlock, and you can see that there's no touch function at all. So in order to differentiate which chip do I want to replace, the Cumulus or the Mason chip, there's a general rule of thumb that if you see a characteristic defect of a gray-white flashing bar, then more often than not, that's a Cumulus chip defect. If you have partial touch, then that can also be a Cumulus chip defect. In a phone like this one with no visual artifacts and full no touch at all, then that seems to be related to the Mason chip, although any phone can be either one of those two touch ICs. So that's really all the guidance that we have in figuring out which one is which. So what I'm going to try to do first is I'm going to try, just for fun, to see if pressing on one of these ICs will actually bring touch function back. What we think is happening is that the chip at installation either was oxidized on one of the balls or for some other reason just didn't make a really great joint. So it was always a weak joint. So you might think, well, let's just reflow both of the chips and see what happens. And that strategy, we used to do that when we originally started seeing this problem about 6-9 months ago now. And we found that that wasn't a lasting solution. Like many sort of reflow based, it's not really repair. Although in this case, if it's a cracked or cold solder joint, reflow seems like it would help. The underlying problem seems to be oxidation on the two parts that need to connect. And you really can't reflow, that can't solve an oxidation problem. You can't erase the oxidation in order to allow the solder to actually bond the chip to the board. You can't do that very well. So for fun, let's see what happens if we just try. Hopefully I can do this without disconnecting the battery. This will be a little tricky. I'm going to try just pressing here on the back where the touch chips are and see what happens. So let me try to just get where they are and press down. I'm going to prompt it to wake up again. And I fixed it. We're done. And so you can see it really is a defect where there's insufficient pressure, that there's not a good joint there. I can press on it, and that's sort of forcing electrical contact. Let's see what happens if I let go. Oh, look, and then I let go, and now touch is gone. So this one might be a good example for us to actually see if we can figure out which chip needs to be replaced. A lot of times you don't have this option. But let's go ahead and start looking under the microscope and see if we can do that press test to figure out which chip we need to work on first. All right, so here we are under the microscope. So I'm going to lay this down. All right, and let's see what we can find in here. And so you can really imagine how if the joint is that weak, that a minor drop can really take out touch functions, that there's really nothing that you can do about it. All right, so let's look at these chips. So this one here that says Broadcom is the right next to the PMIC. This is the Cumulus chip, and this one here is the Mason chip. And there's really no other visual damage to kind of like be a guide in this process. So let's see how I can try to manage. This is going to be fun. Let's try, can we, what could I use that's not conductive because this phone is under power? Probably should have thought about this in advance. I think I'm just going to put some tape over this part of the board. And now let me see if I can press just on Cumulus and prompt it to boot again. And let's see if I can pick this up without disconnecting the battery. Do I have touch? I do not. All right, this is a pretty janky test, but I've never done this before. I've never had one that actually would respond with just pressure. All right, what happens if I press just on Mason? Do it. All right, so we'll skip that. That seemed like a good idea, but fail. And we're going to go with, let's just see what happens if we replace, we really should probably replace the Mason chip because of the fact that there's no visual artifacts, and see if that solves. Mason's also a little bit more technically challenging than Cumulus, so it's probably a good one for our video. All right, so we're gonna get this apart and disconnect the battery. Disconnect the screen and dock. All right, microscope. All right, so how do we go about this job? This is, you'll find that this is not a whole lot different than trying to replace any micro BGA chip like U2 that we already covered in a different video. All right, so the only thing you really need to worry about is that it's very easy to pull a pad under here. This guy is the adjacent audio IC, and let's look and see what's on the other side of the board. So on the other side of the board here, we're really close to the CPU. So we don't want to overheat the CPU, and if we really look kind of directly under that, we're really close to what's under here, which is the BGA backlight driver. So you can, if you use too much heat, you might short some balls under the backlight driver chip, and that would cause you to lose backlight after the repair. All right, so let's go ahead and try to get this chip off safely. So I'm going to, I could, use some preheater and, try to help myself out, but I am going to skip that since most people won't have a preheater. And I'm just going to tape the board down sort of in general. And then I'm going to try to shield or protect the board from heat where I don't want it to go. So for that, I use like a pretty generic shield, like this generic iPad mini shield. So I will tape this shield on top. All right, Wi-Fi chip I'm not super worried about. But we can put a little tape on that as well. Now everybody's always wanting to know, tell me the magical holy grail. What temperature do I use to pull a chip or to place a chip? And the answer is take a big black magic marker and cover over all of that nonsense. Those are just numbers. Even my own, someone that's worked with me lately bought a new station, and he's like, this is not working, it's not working. And I went over to it and just cranked it all the way up because it wasn't performing right. So even though in order to have it work, it has to be at 11, which is supposedly 1,000 degrees Fahrenheit. It's not really 1,000 degrees Fahrenheit because at that temperature is when the board performs like it should. So one sort of, how do you possibly get started with this stuff is to just play around with just regular solder. So if you get your hot air station and you fire it up, then you should be able to just watch what happens when you try to, kind of bead up solder. That looks good. See how it's not super fast or incredibly slow. It's really, really ideal. So I'm going to choose any settings that with the combination of my nozzle, my hot air station, doesn't matter what the numbers say, I want it to perform about like that. Alright, so now I'm going to add flux because I want to use the benefit of flux to help me desolder the chip. It'll melt. It's a gel flux. This is my Chip Quick 291. And then I'm going to grab some tweezers, and I'm going to just kind of start slowly heating this general area. And I'm going to put my tweezers down. I'm going to actually switch hands so I have better control of the air. One of my new hires is left-handed like me, so I'm super excited to train her to do microsoldering because I do think that being left-handed, if you're left-handed, it sort of forces you to be a little bit ambidextrous your whole life, and that really helps out when you're trying to remove chips. So it comes off just like that. Alright, so what I did was kind of apply a little slight bit of upward pressure and some general heating, and then it comes right off. Here's the next thing I need to do. I need to make sure I know the orientation of the chip. So I'm looking for the dot. So there's the dot right there, so the dot goes in the top right. Let's actually flip the chip over and look at it underneath. Alright. And see, hey, what's the cause of the problem here? Alright, I think this is, so there's a pulled pad right there. Right there, and that corresponds to this spot on the board right there. So we need to look up and see whether or not that thing is important to be there, or if it's just a no connect pad, which no connect pads don't really attach to anything, and so of course they're going to kind of come up with the chip. Let's look at the rest of this under here. So look at this joint here, right there on the end. That is an oxidized pad. Do you see that? That's probably why I couldn't get it to, if it was Mason chip, I probably couldn't get touch function back unless I was pressing on both chips. Because to press on both chips, I kind of put my finger there. But when I was just pressing on Mason, I, tried to put the tweezer sort of in the middle of the chip. And it may be that this right here was the original defect, where that just was never a good joint. Look at how oxidized and gray that is. That would be really difficult for solder to bind to. It's not going to be able to make a good joint. So could I have just reflowed this and made that joint again? Let's look at the corresponding ball. So right here, could I have gotten that guy to stick on there? It would be tough. I probably could have, but it would have probably still been weak. All right, so let's first see if we pull any more pads when we go to clean this up. So to clean this up, I'm going to use a whole lot of flux and a relatively wide iron, and I can choose whether or not to, use braid or not, but initially I'm going to start with not using braid. Braid is sometimes overrated. So with a rather fat iron tip, I'm just going to kind of touch these balls, and my goal is really to just flatten them. It doesn't have to be perfect. They just need to all be fairly uniform. Where did this dude come from? Where are you supposed to go, dude? I know you don't go there. It was probably stuck to the bottom of the soldering iron from my habit is to, like if I desolder something and it's stuck to the iron, then I wipe it off in my copper braid or whatever that stuff is called, loofah. And then I probably just picked one up and then delivered it to my board. All right, so let's try to flatten these pads some more. Now this is the one that I really kind of want to focus on over here. Like, see how that does not take solder? Look at that. Let's look at that really close. I can put an iron on it, and I really have to massage and work with it in order to get it shiny again and ready to make a new joint. All right, so I'm going to switch to a smaller tool, and I'm going to get that pad cleaned from its oxidation so that it can be ready to actually make a good joint. There we go. So we just sort of mechanically force that off, and now it's a good looking pad again. All right, so I'm not going to obsess about, is every single little pad on here, perfectly flat and smooth, and I'm not going to run braid all over it and worry about that, because I know from experience that the mason chip, it's really easy to pull the pads. So now I need to address this missing one here and find out whether or not I need that. So the first thing you can do is take a look at it and say, do I see a trace that leads to this pad? And I really don't. So your choice would be, if there actually was service to this pad, a trace would be coming up from underneath the board or from the side, and I don't really see that. And then I'm going to confirm that by checking with ZXW tool, which if there is a if there is a trace there, it'll tell me where it goes. Let's see if I can put you guys on screenshot with me to see that. All right, so let's go over here to ZXW tool, and we are going to look at, I think it's this side. So we're looking at this chip, and it is this pad here. NC, not connected. So that pad was just laying there, not connected to anything, and so therefore, it's easy for it to just sort of come off, which is no big deal, and we don't need to address that at all, so then we're ready to move on. All right, so let's clean off the flux that's on there right now, which is a little bit oxidized itself or burned up. All right, so we're just going to kind of make the flux that's on there not gummy. We want it to be relatively fresh. And try not to leave behind any hairs. All right, there we go. Let's really inspect and see, is there anything here that's going to prevent us from putting on a nice new chip and having it find its way through just regular old capillary action to make a good joint. And I think it looks fine. So let's go ahead and grab a chip. All right, so where do you get chips from? China. China is the source of all things. If you are domestic US you can order them from my buddy Jason at microsoderingssupply.com. Jason is doing a great job of, QC. He's, going to make sure, because he microsolders every day, that the chips that he stocks are going to be the right ones. And every now and then there are quality issues. You might get a bad batch of chips, and it's a lot easier to kind of, follow up on that with a domestic supplier than it is with China. All right. So here's what the new chip looks like. Let's look at it before we install it. And it looks like it has evenly spaced balls, so we're good to go. And we have to remember where our dot went up in the top. Okay, so I'm going to just apply a thin layer of flux. So I really don't want a whole lot of flux. I don't want this thing to like really float. I want it to just have a thin underlying layer of flux. All right, now I'm going to place this chip. And ideally, I want to let it sort of find its own way to some degree. So roughly like that. Now let's see if I can get a little bit more focus for you guys. All right, so now I'm going to kind of come in from initially, kind of far away. And put some heat on there. And what I can do is I can kind of put down some tweezers to just sort of hold it roughly in place, almost like baby gates. To kind of get it initially stationed on there. And now I want it to really kind of find its own way. So I can add more flux that will kind of now be better able to suck under the chip. And now I want to kind of really get that dancing. There, you see it click into place by itself. Alright, and that's about it. Okay, so now we can let this cool down on its own, and then we're going to test to see if we have touch function. If we don't have touch function, then we can troubleshoot the other touch chip. Now this whole idea of, hey, no touch, what do I replace? Which IC do I replace? I really hate because, I get so many requests for help in email all the time. And one thing I've started answering is, I'm not a vending machine for solutions. Use your brain, do some research. So it's really just because this is a super classic problem that I would go straight to replacing this chip. If this were an open-ended problem, a new problem, or something that I hadn't seen, constantly over the last 6 months, then it would be appropriate to go to the schematic and first figure out, is my chip being told to turn on? Does my chip have a source of power? Or is something ahead of the chip shorted to ground, in which case I'm in the wrong spot. So you need to learn how to read schematics. You need to learn how to see what the inputs to a chip, what are the outputs, how do I use my multimeter to measure these things in order to finally, figure out that replacing chip X, Y, or Z is appropriate. And this is part of what we teach at Practical Board Repair School, and we really have a great time. Touch IC is one of the things that we cover, and I think that it's a great general skill to have. I think this problem is likely to go away. It is so rampant. Every shop sees these Touch IC problems that I can't imagine. I mean, I could be wrong, but my guess is that over time we may see Apple do something about it. So they have in the past issued recalls for very specific problem, like the MacBook failing GPU issue, or the iPhone 5 power button. iPhone 5 swelling battery, so very specific product, replacements, and we may see that happening with iPhone 6 and 6 Plus Touch. On the other hand, maybe we won't, because it's such a huge problem that it may be difficult for them to, replace every one. I especially see it in any phone that's had a bad drop, although that's not the only reason that you can get this failure. So when I think about all the phones that are sold as Apple refurbished phones, when you think about that history, in order for a phone to be on the shelf at Apple as a Apple refurbished phone for you to buy as your out of warranty swap, that phone had to come to them from some other customer who, if they just had minor damage, would have just bought a screen swap from Apple. But instead, they had such severe damage that they actually traded the phone in for their own out of warranty swap. So now that board goes back to Apple, where Apple is going to, say, hey, the board's good, the frame was bad, the screen was bad. They're going to take that board, which has suffered a bad drop, and put it into a different housing with a new screen and battery, and then it's going to go straight back to the shelf at Apple to be sold for $299 to the next guy that comes along. And so I'm seeing, when I look around at forums and talk with users, that these refurbished phones especially are going to be specifically prone to this problem. So we may see an Apple recall or replacement or something like that in the future. However, for right now, if you are having this problem, you can go to any shop that is quality microsolderer that should be able to do micro BGA work. And you can, hit us up for, hey, who's near me? Because by now we've trained, almost 100 people have come through Practical Board Repair School all over the world. And so, there may be somebody near you that can do this work. And if not, you can always do mail-in repair to us. That's the heart of our business. And we do fix this by the dozen every week. All right, so let's look under the microscope. We've given that a chance to cool down. And let's see if we've got this on right. Okay. So when you're looking around kind of post-repair, it would be nice. You can sometimes flip the board on the side and actually see the solder balls to make sure that everything flowed nicely. But in this case, we don't have the clearance for that. And then let's look on the other side of the board and see, do we see any evidence of, excess heat on here, which would be, kind of bulging joints and little blubs of solder that are oh my God, I can't get away from the phone. It's my business manager who usually carries the phone. It's Friday and she has gone for a weekend trip to Canada where we can't take the business phone. So it is just, oh my God, this is, oh my God. All right, I'm just gonna have to finish this video. Sorry, I will talk to you in a second. I've made like 4 clips here where I didn't want to like take phone calls on this video, and I just want to test. So it's all cooled down, and let's get this testing done so we can know whether or not touch is fixed, and if not, then we need to go on and troubleshoot Cumulus, or maybe get our, lift our chip or place another one if there's something going on, and keep working on this. But in general, this is a fairly straightforward repair, and you kind of can work on it, get some dead boards in practice, and you'll be fine. All right, let's find a dock. Let's not run over my dock connector. And let's try to get this done before that phone rings again. Okay. All right, so let's see if this can boot up and we can see whether or not we have touch or not. And when I first started, prepping for this video, yay, touch. I was making sure that the board that I had actually didn't have touch. And then when I started pressing on the chips on the back, and touch came back, I was like, oh, now what am I going to use for a video? So I actually just sort of, dropped it on the table, and just that was enough to actually, take away whatever tiny little electrical connection was being made so that it would have no touch again, and we could do the repair here. So, you really want to make sure that you have a robust repair, and I think that I will probably, yep, it still has touch. I'm going to give this board a small drop that won't really hurt anything, but I want to just kind of test to make sure that I don't have the same problem. Maybe the problem was under cumulus all along. So I want to just kind of give it a drop to make sure, that I don't have a cumulus problem that I think I've solved, when really, by replacing the mason chip, I was excess heat was kind of just reflowing cumulus a little bit. So let's give it that little drop, and when I did that before, that made touch go away again, because it was just kind of hanging on by a thread. So this time, now that we've actually replaced the chip with a new chip, we cleaned up that oxidized pad, this should be a robust repair, and we want to make sure that it is actually robust. So let's let this come up again, and if we still have touch, then I'm going to call it a day on that. And this was iPhone 6, no touch, due to a bad mason chip, and it had no visual defects. So there we go. So we have robust touch, and it just survived my drop, and this one's good to go. So get your touch IC problems fixed, everybody. You can mail it into us. If you want to learn how to do it, you can come out to Practical Board Repair School. We just opened up two new sessions, a second one for May, and then also June as well. So we hope to see you at school. Super fun time.